So this is 8.2 and 8.3, so there is a homework that corresponds to it. As you work on it, if you want to check your answers, they're in the binder in the back, so by all means, you're welcome to do that. So let's go ahead and review. I don't know what you know and what you don't know. Do we know the Pythagorean theorem? Yes, we do. So we know that in a right triangle, and we know it's right. So, oops. We have a right triangle. In a right triangle, the square of the length of the hypotenuse, so our hypotenuse is C. The square, so C squared, is equal to the sum of the squares of the lengths of the legs. And so here are our little legs. We take the sum of the square of each of those. So there's your Pythagorean theorem. So you may be given some examples where you are given two pieces of information and you have to use the Pythagorean theorem to be able to find the missing piece. So you have to recognize what you've been given, substitute into the formula, and solve for the unknown variable. So in the first one, it says find the length of a leg. Okay, so I'm looking for a leg. So that means I'm looking for either A or B, right? So I have a right triangle, I'm looking for the leg, and I have the hypotenuse in another leg. So I know C, and I know, I don't care what you call it. Oops. A or B. It makes no difference because they're both legs. So you want to call it A? B? Do you have preference? So B is 7, C is 14. So I take my Pythagorean theorem, A squared plus B squared equals C squared. So we're, in this case, solving for A squared, but you could say it's B squared, plus B squared, so 7 squared, equals C, which is 14 squared. So A squared, which we are looking for, plus 49 equals 14 squared. Did we learn our perfect squares? What was it? You are fantastic. Yes, it is. And then I'm going to subtract 49 from each side. And that's going to give me A squared equals what? $147. And then how am I going to solve for A? I'm going to square root each side. So we're going to start factoring, right? And hopefully you find two factors. So 7 times the square root of 3. So A is 7 times the square root of 3. So practice simplifying radical expressions. You're going to see that like you wouldn't believe in Algebra 2. Okay, let's look and see what we've been given in the next one. Oh, find the length of the hypotenuse. So what am I solving for, A, B, or C? C. So I need to find C. I have a right triangle, and I have my two little legs. So there's one and there's the other. So it doesn't matter which one you call A and which one you call B. They're both legs. And we substitute into our Pythagorean theorem. A squared plus B squared equals C squared. We said A was 4 times the square root of 3. And we're going to be squaring that. B, we said, was 6 times the square root of 2, and we're squaring that so that we are able to find C squared, and then eventually C. Now, in this case, remember, when you square something, you multiply it by itself. So that means I'm squaring the 4, and I'm squaring the square root of 3. So if I really needed to see that, I could expand it and I could say I'm squaring it. If that helps you see it, by all means do that. You could just, you know, square each little base factor and you'll be fine. But if you need to see it, that's fine. Yeah, did you have a question?
No.
Okay, so then I'm multiplying 4 times 4 to get 16. And then the square root of 3 times the square root of 3 is what? Just 3. And again, you do not have to show this step, but if it helps you, please do. Then I just do multiplication. 48 plus 72 equals C squared. 48 plus 72 is Hmm? 120? Mm-hmm. And then I'm going to square root each side so that I can find C. And what is C? I'm looking for two numbers that multiply to give me 120. We might want to choose cleverly, like, you know, a perfect square. Maybe 4 times 30. And then we can take the square root of 4 to get 2 times the square root of 30. And of course, with each of these, you could just substitute that value back into the Pythagorean theorem, see if you get an identity. Do you get a true statement? Right? Hopefully you did your arithmetic correctly. Okay, let's take a look at the next example. Because of course you're going to get an application. We have a ladder leaning against a wall. Okay, so I have a wall and I have my ladder. I like my little pictures. So this is my wall, right? The foot of the ladder, so here's the foot of the ladder, is 3 units away from the wall. So I have been given a leg, I've been given the hypotenuse. How high up the wall does the top of the ladder reach? So I'm looking for this. Again, it's a leg, call it A, call it B, whatever you prefer. I'm going to substitute into the Pythagorean theorem.
How do we know?
How do we know what?
It doesn't matter if we actually call it A, B, or B.
What did I just say? No, doesn't matter. It's a leg, right? A and B are legs. As long as C is representative of your hypotenuse, it doesn't matter which one you call A and B.
Yes.
It's your call, Jackson. Okay, and I'm substituting in my little leg, and I'm going to square it, and then I'm going to substitute in my hypotenuse length. So then I get A squared plus 9 equals 100. So A squared equals what? 91. To find the length of A, that wall, to the top of the ladder, I'm going to have to square root each side, and I'm going to have to be clever. Now, what happens if there are no factors?
It's just
Okay, can we find an approximation to that? A decimal approximation, right? Because really, how high is that? We can figure out what two numbers it's between. Do we know two perfect squares that 9b1 is in between? 9 and 10, because 9 squared is 81, which is less than that. 10 squared is 100, which is greater than that. So we know it's greater than 9, right? So it is approximately 9.5 if you use the calculator.
Wait, what is it?
Is that feet or inches? Feet.
In units?
Oh, this little squiggle here?
Yes.
Oh, that means approximately. This means approximately. Jackson.
wait. So whenever we have a square like that can't be sorted out, we just round.
If we can't simplify it,
If we can't.
if you can't simplify it, it depends on the problem. You can leave it alone and say A is the square root of 91. If we want to know an approximation, we'd say it's you know, between 9 and 10. You could say that if it's a word problem, because we know the perfect squares it falls between. Or we could use a calculator and get the decimal equivalent. How would I do that? Put the square root of 91 and it's going to give you approximately 9.5.
And I can't just say that A is equal to the square root.
You could, but I mean, if you really wanted to get a feel for how tall that wall is, I mean, does that really, you know, I'd like to know that it's between 9 and 10. We know it's less than 10, right? For sure. All right, now here we have a beautiful diagram. Let's see what we can deduce from this diagram. Is there anything that I do know? I'm solving for the altitude x.
Oh,
What do I know? Anything?
We know the length of the second legs for the right triangles.
We do?
We do, because 40 is like,
So this whole thing is 40.
yes, ma'am.
Mm-hmm.
And 26 is the length of the rectangle. So we just take that out.
Okay, so you're saying that this is 26 because this is 26 because they're parallel in the both altitudes, right?
Yes.
Okay, that is excellent. So I know this is 26. So that means the sum of this and this, right? If I took 40 and I subtract 26, what do I get? I get 14. So I know that 14 is the sum of these two. And those are congruent. So they're each 7. Does everybody see that? That's excellent. Well, because I know the length of this leg, and I know the length of this leg, and those are the same. They're both right triangles, and I know these are the same. So therefore, I know these are going to be the same.
Isn't like angle D and angle C?
Angle D, yes, they are. Isosceles trapezoid, yes. Okay, so now how am I going to find x? Well, the Pythagorean theorem, of course, right? So what do I know from those triangles? A squared plus b squared equals c squared. Do I know A? Well, yes, if you let that equal A. Do I know B?
No.
No, that's what I'm looking for. Do I know C?
Yes.
Yes, I do. That's the hypotenuse. So then I have 49 plus b squared equals, do we know 25 squared? 625. And then we're going to subtract 49 from each side so I can isolate the b squared. So b squared equals?
576.
You are fantastic. And do we know anything about that number?
Yeah, it's just
It's 24 squared. So x is 24. Good job. Good job. Those perfect squares will serve you well. Emma, does it make sense? At your strange little table over there. Now, we know the Pythagorean theorem says that if I have a squared plus b squared, that's going to equal c squared. But what if we have the converse of that? What does that tell us? That says that if the squares of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then I do have a right triangle. So instead of starting with the right triangle, yes, yes. So it's, I mean, it's the same thing, but we're, instead of given the if statement, we have the converse of the if statement for the Pythagorean theorem.
So it's c squared equals b squared plus a squared?
Yes.
For the first diagram, how do you assume
For the first diagram? Well, okay, so the example? Yes. You are absolutely correct. Okay, so if I'm looking at these,
Oh, wait, you can square all 3 of them and see which one's the biggest.
well, yeah, but you should know which is the biggest, right? Because what's 8 squared?
64.
So is this not bigger?
It's not.
Eight squared is 64, right? So this squared is what?
Bigger.
Is bigger. So that is your hypotenuse, right? We don't know which is the right angle. You haven't been given that, right? That's what we're trying to show. So we're trying to show, are these right angles? So I know that this is the largest. So 8 squared plus 7 squared, the question is that equal to the square root of 113 squared? So I have 64 plus 49. Does that equal 113? Yes, it does. So it is a right triangle. Yes, it's a right triangle. Because a squared plus b squared equals c squared. So now we know, Jules, right? Now we know that's a right angle. Okay, now let's look at the next one. Okay, they kind of give us, we know which is the longest one, that 4 times the square root of 95. But the question is, does 15 squared plus 36 squared equals 4 times the square root of 95 squared? Well, 15 squared is what? Yes, 36 I don't really expect you to know. And then 4 squared is 16, and then square root of 95 squared is 95. So again, we're trying to see if this is true. If this is true, then I have a right triangle. And then if I multiply on the right-hand side, I get this. Oh, if I add the left-hand side, it does not equal. So close. Not a right triangle. Yes, ma'am.
So when you're square rooting or square root 95, the 95 then staying because you're getting rid of the square root.
Yes, the square root of something times itself just takes it out of the radical. Yep. Now, I think you know about Pythagorean triples, like the 3, 4, 5 triangle. That's the most common, right? The 3, 4, 5. We all know 3, 4, 5 is a Pythagorean triple. But there are other very popular ones. Now, you could sit here through each of them and say a squared plus b squared equals c squared. And you could take these little legs values, right? If you know them, and you can substitute in here, and then you could take the little hypotenuse and you can substitute in here, right? And we could find the missing piece. But these are ones that are very common and you will see a lot. So I'm going to, just give them to you, but, make sure that you would be able to get them, right? These are very common ones that are often used. The most common really are these. In other words, if you see those, there's no work for you to do if you recognize them. So these are Pythagorean triples.
Wait, is the hypotenuse that's below 25 to 17?
Yeah.
Oh, okay. Also, whenever you separated or whenever you separated the sides of the table, which ones are the common ones that will be single line?
Well, really, mainly up to here, you'll really see.
Oh.
But one thing to point out is that,
saying from like 8 up or from 9?
oh, up here, these are the most common. But really, you should, recognize all of them. I mean, it's just add 3 more to that. Now, in addition to these being very popular Pythagorean triples, I want to point out that any multiple of a Pythagorean triple is also a Pythagorean triple. So what do I mean by a multiple? Well, if I take each of these, so this was we said was, a very popular one, 3, 4, 5. If I take the 3, the 4, and the 5, and I multiply it by the same constant, I don't know, let's call it x. Any multiple of that triple is also a triple. So let's say I let x equal 1. Well, I have the triple that I began with. If I let x equal 2, what is that? What would this be? Okay, you see what I'm saying? What if I multiply it by 3? Yes. And what if I multiply it by 4?
Well,
So you understand what I'm saying? If you know these triples, any multiple of those is also a triple. So that's true for this one. In other words, 5 times x, 12 times x, 13 times x. That's another popular one. So if I said x equals 2, what would you have? What if I said x was equal to 4? Or no, let's do 5.
Right, I did 25. Wouldn't it be 26? 13.
I'm multiplying it by 2. So
You read
2,
25 and
10,
26.
24, 2, 26. Oh, yes. Sorry. I was like, what are you talking about? Yes. So let's do 3. If x is 3, what do I have?
15, 36.
39. Okay, so any multiple, right? You understand that notation? Yes? Okay. Now, there's 2 theorems that help you understand whether we are dealing with an acute triangle or an obtuse triangle. So these theorems correspond to these inequalities. If the square of the length of the longest side of a triangle, the longest side being C, if C squared is less than the sum of the squares of the lengths of the other 2 squared, A squared plus B squared, then the triangle is acute. It's an acute triangle. If this is true, it's an acute triangle. If the square of the length of the longest side, the hypotenuse C, is greater than the sum of the squares of the lengths of the other 2 sides, then the triangle is obtuse. And then, of course, we know that if it's equal, then it's a right triangle. That's the Pythagorean theorem. That's kind of neat. Now, we also have already talked about the triangle inequality theorem that says the sum of any 2 sides must be greater than the third side. So A plus B must be greater than C for it to even be a triangle, right? So if this isn't true, we don't even have a triangle, much less worry about the squares being greater than, less than, or equal to C squared. So let's look at these 4 examples and let's talk about whether they are triangles, and if so, what kind of triangles they are. So I look to my longest side. So that's C. So that means these are A and B. So if I look at A squared plus B squared, how does that relate to C squared? Well, I have 14 squared plus 48 squared. The question is, how does that relate to 50 squared? I don't know. So 14 squared is 196. I don't expect you to know 48 squared. It's 2,304. 50 squared, you can do that. What is 50 squared? Yes, okay. And then if I multiply add the left-hand side together, what do I get? I get 2,500. So since 2,500 equals 2,500, what can you tell me about this triangle? It is a right triangle. Good.
I thought that so for another way you can do this, you did 14 plus 48 is greater than 50.
Say that one more time.
You did 14 plus 48 since it's greater than 50.
That just tells me it's a triangle.
Oh.
It doesn't tell me what
Oh,
type of
okay.
triangle, but I like what you're thinking. Okay, what about the next one?
It's not possible.
It's not even a triangle, right? Because 3 plus 15, how does that relate to 20? It's less than 28. Oh, what is going on there? No, what am I saying? 28, 18. Not even a triangle. Not even a triangle. What can you tell me about the next one?
Right.
Oh wait, it's an obtuse triangle.
Is it?
Because
Square root of 3 squared.
4, which then equals 7.
Oh, well, let me put a little box.
Isn't it right?
wait, no.
Because if you square it,
Yeah,
Wait a
just
minute.
get 3 equals 4. But 3 plus 4 doesn't equal 5.
Actually, wait a minute.
No,
It's an acute triangle because
No, it's
3
not one of
plus
those
4
like,
is greater than 5.
what's it called? Pythagorean triples.
Oh.
Right?
No, it's
Oh,
not.
No.
it's only-
3, 4, 5 are the Pythagorean triples. Square root of 3, square root of 4, square root of 5 makes it, this is greater than. What happens if it's greater than? It's an acute triangle, right? Greater than, it's an acute triangle. A squared plus B squared is greater than this. This is less than that, right? You need to be able to read those either way. You do see that, right? I can rewrite this as A squared plus B squared. Let me do it here. A squared plus B squared is greater than C squared, right? And this one, A squared plus B squared is less than C squared. And so since we said it is greater than, it made it acute. Okay, what about the next one? What can you tell me about the next one?
It's an obtuse.
7 squared plus 8 squared, 11 squared. We're trying to figure out how those are related. So I have 49 plus 64, 121. So 113, 121. This is less than. It is obtuse. Oh, that's it. That's it.
Wait, it's only 10:46.
How did we- How did we do that so quickly?
It's only 2 pages.
It was 3 pages. Wow, that's it. Okay, so you have the rest of class to work on your homework. As I mentioned,